All right, guys. Unit A, lesson 1, probability. We're gonna start off with probability. So, like we had on our worksheet, it says probability is the chance an event will happen. Okay. Now, one thing. What's the question? Oh, sorry, Chance. I'm gonna say chance a lot. So sorry. All right. One thing we talked about on that introduction worksheet was, is there a way to change probability? We talked about. We just got done talking about the dice and rolling the dice and how a die has 1 out of 6 chance of rolling any number, right? Yep. Now, if I roll a dice once and I get a 2, what's my probability of getting a 2 the next time I roll a dice?
1 6.
Still 1 out of 6, right? Now, that's with a 6-sided dice, right? Right? What if I change my dice instead of being 6-sided to 4-sided?
You have 1 out of 4.
Okay, I have a 1 out of 4 chance, don't I? If you're wondering, well, it's number 1 to 4. Okay, if you're number 1 of 4-sided dice, look like it's kind of pyramidal. Looks like a pyramid. Okay. So, if I want to change the probability of rolling a 2, do I use the same dice or do I get a different dice? No, if I want to change the probability of rolling 2. I have to use a different dice, right? Because a 6-sided dice is a probability of 2 out of 6. A 4-sided, or sorry, 1 out of 6. Okay. A 4-sided dice is a probability of 1 out of 4 to roll a 2. Right? So the only way to change the probability of getting a 2 is to change the situation. Okay. Another way we can think about it. If I have a full deck of cards, how many cards are in a full deck of cards?
52.
52, right? If I want to draw the ace of spades, okay, it's 1 card, right? What's my chance of drawing that, Travis? What do you think? 1 out of 52. If I grab them at random, 1 out of 52 chance I'm going to get the ace of spades, right? Okay. Now, what if I'm going to keep drawing until I get an ace? All right. If I draw that first card, not an ace of spades, I'm going to set it down. How many are left in the deck still?
51.
51. Okay. Now what happened to my chance of getting the ace? It's increased. Instead of being 1 out of 52, now it's 1 out of 51. Okay. Now, if I were to draw a card, King of Clubs, and then put it back in the deck, okay, probability would stay the same. Good. So, if I'm not changing my situation, there's no way to change the probability. Okay, with the 6-sided dice, the dice doesn't remember what you did before. If you roll a 1, okay, you don't have to roll all 5 numbers to get back to 1. Okay, anytime you roll, it's a 1 out of 6 chance, just like drawing cards. Okay, if you draw a card and then put it back, it's not going to change your probability to draw a certain card at a time. Okay, so probability is a chance an event will happen, and the probability does not change. Does not change unless what? Unless we change what? Situation. Okay, now, there's 2 ways you report probability. One way is percentages. Okay, for example, talked about a little bit early, 30% chance of rain. Sorry again, chance. It's spelled differently though. It's not? You're not SE? Oh, different chance then. Sorry. Take it easy. Alright. So there's percentage, okay? And then there's a ratio. One way we talk about ratios is like 3 out of 4. For example, if I had 4 bats, I got 3 hits, right? Or if I faced 4 shots and stopped 3 of them, right? Then my save percentage or my batting average would both be 75 or 0.75, right? Or I can write this as a probability of 3 over 4. Okay? So 3 out of 4 is also 3 over 4. 75%. 75%. So they're kind of interchangeable. 30% chance is like 3 out of 10, right? Ratios and percentages are definitely interchangeable. All right. Any questions about probability and chance and how we're going to report them? All right. I think we got a pretty good understanding of probability, so we're going to move on to something called sample space. Right. Now, a sample space is a list of all possible outcomes for a situation. Right. Now, we're going to look at a situation where we have 2 dice. Can't talk. 2 dice. We're going to talk about a red dice and a green dice. Okay? So I have a red die and a green die. All right? And we're going to talk about the possible outcomes and probabilities from there. So while I pass out this worksheet, I want you to think about how many possible outcomes are there for these 2 dice. Okay, when I roll these 2 dice, how many possible outcomes? Don't shout it out. Just think to yourself, how many possible outcomes are there for these two dice? Now, if you're taking notes, please continue to take notes in your notebook and just use this for examples. Okay, the things I write on the board are things you should write in your notebook.
So we have to take into consideration if there's two dice.
Okay, we have two dice. How many possible outcomes are there?
What?
First try.
First try.
1 on 6.
How many dice are there?
I think the 6.
5.
No,
Just 5.
it's like,
Chance.
yeah, but
We gotta do 1 6.
they have the same
10
number.
26, 10
So
26,
there's
10 26, 10
two
26.
more chances.
So it's 1 over 65th.
Like if you want to roll 5
Six
or like 1 6, then it turns into, since there's 12 sides, it stays at 1 6, or it could be 2 12.
1 out of that. Alright. So, does anybody think of how many possible outcomes are there? If I roll 2 dice, how many possible outcomes are there?
12.
12. Why 12, Michael?
They both have 6 sides, theoretically.
Okay, they both have 6 sides?
Yeah.
Okay. So
There's 12.
6 plus 6 is 12?
There's 6 options because they have the same number.
Okay. Now, did you consider the fact that there's no way to get 1 when you roll the dice?
I don't get what you mean.
If I roll 2 dice, I get 2 1s, right?
Yeah, that makes it 2.
So using your justifications, there are really 11 chances then?
Sure.
Okay. So you're basing solely on adding the 2 together, right?
Sure.
Okay. Now, that's not a bad approach, but think about how many ways you can get a certain number. Is there only one way I can get 9? No. Is there only one way I can get 7? No. Is there only one way I can get 2?
Yes.
Yes, there's only one way I can get 2. Okay. So your answer, there are 11 outcomes if we add them together. That is correct. But those aren't all my outcomes. Okay. There's more outcomes than just 11. Okay, because there's multiple ways to get each number. But good start. Okay, Greg, you had an answer. What was it? What is it? 36. How'd you get 36?
I'm going to say like 10,000.
Okay, so take the number of outcomes for each and multiply by each other, right? 1 dice is how many possible outcomes? 6. The other dice is how many possible outcomes? 6. 6 times 6 is 36. Okay. So when I roll a 1 on the red one, there's 6 options for the green one, aren't there? Okay, and so we can keep playing the game. 2 on the red, 6 options for the green. If we multiply 6 times 6, then we get our total number of possibilities. All right. So anytime you want to figure out the total number of possibilities, when you're using the dice, all right, or if we're using 2 dice, or if we're using like a dice and a spinner, you multiply the options together. For example, if I have 1 dice and I have a coin, right? The dice is how many options? 6. The coin is how many? 2. So if I roll a dice and flip the coin, right? How many possible outcomes are there? 12. Right? We got a tail with each number and a head with each number, right? Okay. Christian said 3 because he's thinking about landing on the edge, right? Okay, well, assuming that doesn't happen, very unlikely. Okay. We have 12 probabilities or 12 possibilities. Does that make sense? Okay. Now, one more. Let's say I have a spinner. Okay. You guys ever play Life? Game of Life where you spin, you get 12 openings, right?
I play like
Let's say it's a little simpler version of Life. Okay. We have 4 options. Okay. So I'm going to spin the spinner. I'm going to roll a die, and I'm going to flip a coin.
Bro, that's how it
No, I'm just saying. I was getting context with the Life game.
I have 48.
Okay. So I'm going to spin the spinner.
You have 48.
Okay. How many options are here?
4.
4. So spin the spinner. Roll the die. How many options for the die?
You have 48.
6. And flip the coin?
2.
2.
48.
How many, Michael?
48.
48. Okay. So if I want to figure out the total number of possibilities, I take my options for each of the things I'm picking and multiply them together. Okay, does that make sense? So in order to figure out the total possibilities, we take the outcomes for each of them and multiply them together. So if I'm talking about the red die and the green die, and I want to make a sample space, which is a list of all possible outcomes, how many things are going to be in my list?
48.
No. 2 dice, right?
Oh,
6 and 6. What's 6 times 6? 36. So how many entries will my sample space have? 36. Okay, does that make sense? Yeah? All right. Now, for our dice, gentlemen, please pay attention. Okay. We have 2 examples of a sample space up here already. For the green die, 1, 2, 3, 4, 5, 6. These are all the outcomes on the green die, right? Right? You can think of this as the sample space for the green dice. Okay. For the red dice, these are all the possible outcomes, right? This is the sample space for the red die. Okay, it's a list of all the outcomes. Now, when I put them together, we get a sample space for rolling both of them. Now, when we make up our sample space, we're going to write them as G, comma R. What do you think I mean by that? Okay, the green number, comma the red number. Okay, this is not an ordered pair like X, comma Y. It looks similar to it, but it's not an X, comma Y pair. Okay, so the reason I'm doing that is to keep track, because does order matter? Is 1 on the green die and 2 on the red die different than 2 on the green die and 1 on the red die?
The color's different.
Okay, if I roll this, 1 red and 2 green, is that different than rolling?
Either way, it equals 3.
Either way, it equals 3, but is it a different outcome than 2 on the red and 1 on the green?
Yes.
Yeah. Okay, so you gotta keep that in mind as we fill in the table. That's why the order we put them in matters. All right, so how are we gonna fill this in? Well, the first box is easy. 1, comma 1. What about this box?
1, 2.
1, 2. Okay. Now the way I have it ordered really doesn't matter. I just picked an order, green, comma red. When you're doing this on your OYO, on your homework, on your test, just as long as you tell me which the order is, that's fine. I don't care which one you put first, which one you put second. Okay, what about this one? 1, 3. Okay, I'm gonna skip to the next. I'm gonna skip to the next column. What about this one? 2, 1. 2, 2. 2, 3. 3, 1. 3, 2. 3, 3. Okay, can you guys fill in the rest? Okay. I'd like you guys to fill in the rest. So take a few moments here and fill in the rest. I'm sorry.
Yeah, you lost the branch. Yeah, you lost.
What part? Really, or you just joking? Juan, do you really need help, or you just joking around? Okay.
You pause that.
Nope.
You should edit it then.
What?
You should edit it.
Why?
So there's not a big quiet, awkward silence.
Well, now we're filling it with meaningful conversation.
Gives kids at home.
Done. Yeah, it gives Christian time at home to redo the notes.
Yeah, but if worldwide people watch this, they're gonna be like, "Wow, this is awkward." They're gonna turn it off.
It's okay, they can just fast forward. Alright. Here's our sample space. Does you guys look similar?
No.
Yeah? Okay. Like I said earlier, this worksheet I've given you is to be a supplement to your notes. Don't just take your notes on here, okay, because you'll miss stuff. Alright, so this is a supplement. It's our examples for our notes. Okay? So this is a sample space because it's all the possible outcomes. Right? These are all the possible outcomes for rolling 2 dice. Okay? Now, how many entries are there?
36.
36. Did you count?
No.
No, but we talked about that earlier. 6 times 6. Right? Now, how many times does 3, 2 show up in here? Where I get 3 on the green die and 2 on the red die. How many times does it show up? Once, right? 3, 2, and 2, 3 are very different, right? 3 on the green, 2 on the red, 2 on the green, 3 on the red. Those are different outcomes. They both give us the same number of 5, right, from playing a game. But right now we're not worried about playing a game. We're worried about the number. We're just worried about 3, 2, and 2, 3 as outcomes. Okay, does that make sense? So, are there any outcomes that have more than one way of getting them?
No. Yeah.
All of them?
Yeah.
Okay. Are there any outcomes that happen twice?
Yeah. No.
If we're adding them together, yes.
All except
But when
for 6, 6.
we're talking about rolling them, right? There's no outcome that happens twice if we're keeping track of the number on the green one and the number on the red one, right? 4, 1, 4 on the green, 1 on the red. That only happens once. Okay, 1 on the red and 4 on the green. That happens once as well, right? So that number happens. That sum happens a couple times, but just that order only happens once. Okay, so each of these possibilities is what we call equally likely. Why do you think it's equally likely?
Except for 6, 6.
They all happen once. No, 6 times 6 only happens once.
But it's the same thing.
Right, but it only happens once. All the rest of these combinations only happen once. Okay? So the probability of getting any of these combinations is 1 out of 36, right? Right? So they're what's called equally likely. Right? They're equally likely. Right? So you can put that in your notes. You can put combinations are equally likely because they all only happen once. Okay. Now, for probability notation, some of you might be looking at this probability notation thinking, oh no, he's getting back into functions, right? Doesn't this look like functions? Remember like f of 2, f of 3, you guys remember that? Okay. This notation is the same, but they're not alike at all. Okay. So when we talk about probability notation, right? Probability notation, what this is, it tells us how to figure out the probability. Okay. Now if I have p of 1, 2, right? This is the probability, and this is where, I know this is an example on your worksheet, okay, but please write this down in your notes. For p of 1, 2, and I have a little arrow. I'm not worried about the probability yet. We're worried about what this means. Okay? This means it's the probability of getting what? Probability of rolling what?
1 green.
Good. It's the probability of rolling 1 green, 2 red. Oh, 3 L's in rolling. Probability of rolling a 1 on green and 2 on red. Now, if you look at your sample space, how many times does 1, 2 occur?
1.
Look at our sample space. How many times does 1, 2 occur? 1, 2. Once, right? So what's the probability of 1, 2?
136.
1 over 36. Right? So when we have P of an event, right? P of an event, this is the probability that event occurs. Okay, does that make sense? That's the probability that event occurs. So when I have P of 1, 2, that's the probability I roll a 1 on the green, a 2 on the red. Okay, the 1, 2, that has nothing to do with this 1 and that 6. Okay, this 1, 2 is saying what's the probability I roll a 1 on the green and a 2 on the red. So I look at my sample space and I see 1 green, 2 red only occurs once. So that's where I get this 1 from. Okay? Fine. So what do you guys think goes on the top and bottom of these fractions? I guess here's a better question. What does the 36 represent? Total number of what? Okay, our total possibilities are our total outcomes, right? So the 36, like Greg said, is our total number of outcomes. Right? 36 is our total number of outcomes. What's the 1? Where does the 1 come in? 1 out of 36. Where does the 1 come in?
Because that's the one we roll a lot of.
That can only have a 1.
That's what I'm looking for, right?
Yeah, that's what we got.
When I'm looking at 1, 2, the 1 is what I'm looking for. Okay, can I do that one? Okay. So, what is the 1 is how many times that happened, right? Right, it's how many times I got 1, 2. So the top number is what we call the number of successful outcomes. Okay. So when we're figuring out our probability notation, when we're figuring out our probability, we take the number of outcomes that meet the event, number of successful outcomes, divided by the total number of outcomes. Right? Does that make sense? Does that make sense, guys? Yeah. Okay, so let's talk about what a couple more of these probabilities mean before we look back at our sample space. So, probability of the sum is 11. What does that mean? What does sum mean?
All together when you add.
Add them, right? Sum means to add. So if I'm looking for the probability of the sum is 11, that means I'm looking for the probability the two dice add to 11. Okay. Probability of doubles. Or probability with doubles in there. What does that mean? Means the dice have what? Same number. So P of doubles means probability the probability of two dice have the same number. Okay? So that's probability of doubles. Right? Does that make sense? Does that make sense? Sometimes it's straightforward, sometimes it's confusing. Are there any questions about how I figure out what those mean? Yeah, please ask. Now let's figure out these probabilities. Okay. Let's figure out these probabilities. You done already, Michael? Yeah. Okay. Let's do the second one first. The probability of doubles. So looking at our sample space. Okay. Looking at our sample space. If I want to figure out the probability of doubles, that means I gotta look up here and look for what? Means I gotta look for what, guys?
The same number.
The same number, right? So what's an example of the two dice showing the same number?
3, 3.
1, 1, 3, 3. So how many times did that happen? 6. So if you look, our doubles are right down this diagonal, aren't they? Okay. So our probability of rolling doubles then is 6 out of 36. So probability of doubles.
Did you write 1/6?
Yep, you can write 6 out of 36, which reduces to 1/6. Okay, so either one of those will work. So 6 out of 36 or 1/6 for rolling doubles. Now the second one was the probability the sum is 11. Okay, probability the sum is 11.
They all go.
Now I want you guys to find all the ones where the sum is 11. What does sum mean again? Add. So if I'm going to find the sum, that means I'm going to take the two dice and do what with them?
Add them to get 11.
Add them together. It's just like playing Monopoly now, isn't it? Okay. So how many do you guys see? 2. We find 2?
2.
The sum is 11. The probability of the sum is 11. Okay. So we got 2. We got 6, 5 and 5, 6, right?
Yeah.
Okay. So what's that probability then? 2 out of 36 or 118. Okay. I like them better reduced. Okay, please reduce them if you can. Now, quick question. Can anybody figure out the probability of ones that add to, we'll go with 4. Probability of them going to add to 4. Okay, Michael says there's 3. You guys agree?
Yeah.
Yeah? So 3 out of 36 or 1/12? What are the probability they add to 7? Okay. We got 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Right? So 6 out of 36 or 1/6. Now, does anybody see kind of a pattern here with these adding up? They go diagonally, right? The ones that added to 11 are right there, right? The ones that add to 7 are right there, right? So if I draw diagonals,
competition.
Yeah.
Yeah, but I don't work at any children's parties.
So you work at adult venue?
Nope. Old folks home. That's it. It's easy to sneak up on. Okay. 1, 2, what's that? 3. Hey, look, diagonal. 2. Oh, that's a 2.
You forgot all.
Okay. So we got the ones down here too, right? 2, 6, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. What's that? 8, 3, 6. Okay. I think it's kind of cool, right? But the diagonals, starting bottom left, going to top right, are our sums. Okay. There's similar diagonals to the difference, but we'll get to those later. All right. All right. Any questions about that? Any questions about figure out the probabilities? So which one's the most probable? 7. Why 7, Greg?
6 options.
Okay, we got 6 options, right? And we can almost think it's the longest diagonal here, isn't it? Yeah. All right. There's no questions? All right.